All right, today in topic 8.8, we are still working with volumes, but now our cross sections are some different figures. Instead of Scrabble pieces and so on, we're going to have triangles and semicircles. So let's look at this first example. Find the volume of an object with the base bounded by the x-axis, x equals 9, and y equals the square root of x. So there's our square root of x. I do think pictures are very important when you're doing these problems, just to make sure what our parameters are and make sure that we've got things in the right place. And so we're also bounded by the x-axis. We've got a boundary down here, and we've got a boundary at x equals 9, like this. All right? Now, with isosceles, right triangle cross sections. An isosceles right triangle cross section means that those two legs are the same. All right? And that's what we're slicing off. It's actually a little three-dimensional slice like that. And those, remember, they tell us that the cross sections are perpendicular to the x-axis with the right angle along the x-axis. So my triangle, you can think of triominoes, like a triomino piece, so to speak, except they are a right angle, is sitting that way, and the right angle is down here. All right? So what I have here is just the area, the volume of this isosceles triangle, which is always the area of the base, and the area of the base is a triangle, 1/2 the base times the height, times the height of the figure. All right? So what is my base and my height? Well, my base and my height both come from these function values. So this is going to be the square root of x, and this is going to be the square root of x, since it's isosceles. So both of those go in here and here. This is going to be my dx, and we're ready for an integral. My integral is 1/2 the square root of x times the square root of x dx from 0 to 9. And of course, the square root of x times the square root of x is x. So this is 1/2 the integral from 0 to 9 of x dx. All right? So antiderivative, this one's pretty easy. X squared over 2 times 1/2 makes it x squared over 4. We're going to evaluate that from 9 to 0. And we get 20.25. Sorry, that is not an x to the 4th up there. All right. This is supposed to be 20.25. Let's go to our next problem. Find the volume of an object with a base bounded by the x-axis, y-axis, and y equals the square root of 4 minus x with semicircular cross sections. The cross sections have their diameters in the base and are perpendicular to the y-axis. So our cross sections are now running this way, which means we need to do this with respect to y. All right? And so what we've got here is a cross section. It's like half of a tomato slice. If you could cut a nickel in half, if you could cut a quarter in half, so on. That's what we're dealing with here. And if I wanted to find the volume of any cylinder, this is just a really flat cylinder, it would be pi r squared h, but since it's only half of it, it needs to be divided by 2. All right? So, I need to come up with something for this radius. All right? So the first thing is, let's take care of this function. It needs to be with respect to y, so I'll square both sides, and I have y squared equals 4 minus x. Subtract 4, y squared minus 4 equals negative x. So x winds up equaling 4 minus y squared. All right? So, because this is the function right here, this value is the entire function value, but we only need the radius. So we need half of that. So the radius is going to be 4 minus y squared divided by 2. All right? So we're pretty much ready to roll on this problem now. We're integrating 1/2 pi r squared h. That's what we're integrating. 1/2 of the volume of the whole cylinder. All right? So the h, this is the h over here, so that's what we're going to call our dx. My radius, we just said, is right here, so I'm going to have 4 minus y squared over 2, but it's going to be squared. And then I have a pi halves I can pull out in front. All right? And our limits of integration are going to be from 0 to 2. How did I come up with that? Because of this function here intersects up here at 2. It's a sideways parabola. We could just solve it like a regular parabola, find the intercepts, and we would see that that'd be 2. All right? So you do have to be somewhat cautious on this problem with your fractions. We are squaring this thing right here. All right? So that means the denominator is going to be a 4. So I'm going to have a pi halves times the integral from 0 to 2 of, that denominator is going to be a 4, so I can pull this 1/4 out in front like that. And I'm going to have 4 minus y squared, the quantity squared. I said dx, but I guess it should have been a dy. All right. And we can just bring that one in with our Math 9 on the graphing calculator. It's 6.702. So again, setup is everything on these problems. Let's talk about equilateral triangles. One where we've got the volume of the shape with the base bounded by the, we've got a circle again. We did that the other day. So we've got a circle and cross sections that are equilateral triangles perpendicular to the x-axis. So my equilateral triangles are going to be running this way. So once again, we know that we need to solve this thing for y. We did that the other day. Y equals the square root of 4 minus x squared. And we know that that can tell me this distance right here. All right? So now we need to take a look at our equilateral triangle, and how would I find the volume of one of those? So equilateral, all three sides are the same. This is a 60. This is a 60. When I cut this in half, each of these are 30s. All right? And the base down here is what is lying on the circle. So I need 2 of these to cover the base. All right, the base of this equilateral triangle is going to be 2 of those square roots of 4 minus x squared. All right. How do I get the height? The height comes from the 30, 60, 90 triangle. All right. And if you remember our rule, I can find this height by taking the shorter leg, I'll just put SL, times the square root of 3. Well, the shorter leg is just this distance in here, which is half of this. So that shorter leg is just the square root of 4 minus x squared. And that means that the height is the square root of 3 times the square root of 4 minus x squared. And we've done a lot of the hard work on this problem now. All right? The volume of any triangular region like that is going to be 1/2 the base times the height, that's the area of the base, times the thickness, the height, all right? And so my base is the 2 times the square root of 4 minus x squared. This height right here is this right here. Okay, so it's this times that. This height right here will turn into my dx. So my integral will be 2, I've got 1/2 times 2 square roots of 4 minus x squared times the square root of 3 times the square root of 4 minus x squared dx. We're going from -2 to 2. A lot of times, one thing that's nice about these is they kind of clean up a little bit after you get them rolling. You can see that I have a square root times a square root, so that goes away. I've got a 1/2 times a 2 here, so those go away. So I just wind up with the square root of 3 out in front of my integral and just a 4 minus x squared dx. The antiderivative is not going to be too bad on this problem. We're going from -2 to 2. Our answer, correct answer, when you work that out, should be 18.475. All right? And then the next problem, which we don't have to spend a whole lot of time on, is just the same problem, all right? But now our cross sections are semicircles. Okay? So it's still a circle, but what I'm slicing off is a semicircle. So I'm going to use volume equals 1/2 pi r squared h. All right? My h will be my dx. This one's a lot easier than the last problem because this right here is the radius, and it's just the square root of 4 minus x squared. This one's a lot easier than the last problem. All right? So my volume is going to be 1/2 pi, the square root of 4 minus x squared squared, times the height, which we know is going to be dx. So this thing, my actual integral, would just be pi halves times the integral of, since I square a square root, it goes away, 4 minus x squared dx, and we're just from -2 to 2, and we would get 16.755. And we will stop there for today on topic 8.8.